Very good evening to everyone, all the way from Malaysia. It's midnight over here. All right, let me introduce the topic. The research study is about enhancing STEM education through the simulation-based learning. It's actually a study on the student engagement and comprehensive in foundation courses among the foundation students. Yeah. All right. So the idea here is like we want to find out or to bridge the gap between the theoretical knowledge and the practical understanding among the foundation students. And then these simulations provide an effective and alternative to the traditional experiment. Basically to overcome the challenges like, when you want to do like high cost, resources consumptions, and environmental impact. All right, so this case study explores an initiative focused on selected modules and collaborating with the lecturers to integrate simulation-based learning to their teaching practices. And we want to evaluate the impact of this approach on student engagement and their learning outcome. And also the teacher's experience by using this sort of approaches. So basically, this is the introductions of the topic. Yeah. All right. Let me drive through to the problem dimensions that we have identified for this research study. All right. Basically, it's about the what we can see or what we encounter over here, especially to deal with the foundation students teaching the technical modules such as like programming or science modules, something like biology, chemistry, maths, this sort of subjects. We often found that the students struggle to grasp the abstract concept and connect to the real knowledge and the knowledge to practical applications. And many students find out the lack of opportunities to apply their learning in real-world scenarios, hindering them to see the relevance of their study. Like, for example, they study certain topics in chemistry or certain topics in biology or even in programming. But they don't know where to apply, why they need to study, how to apply in real world application later on when they graduate. Yeah, so this is the problem that we often encountered among our students over here. And a main reason or main problem that we found here also, due to this traditional lecture-based environment, we found that the student engagements are not good or lack of student engagements, especially when we have bigger groups or a large classroom environment. And also, educators requires platform to sharing their challenges and the best practice to improve the teaching and foster professional development among them. So this is the underlying problem that we identify for this research study. And moving on with the design and development approach, basically on the methods, what we did is like we come up with the team or group of lecturers who are willing to share or initiate the effort to explore the simulation-based learning to see or to enhance the student engagement and improvement in order to improve the conceptual understanding. So that is our first step. And then moving on with the discussions on the tool selection. So basically, I would say that for this study purpose, we select four modules, basically a programming modules, biology, chemistry, and communication networks. So these are the four modules that we select kind of to do the pilot study. And then we discuss about tools that we can use, something like simulations that we can incorporate in our teaching, not forgetting the learning outcome. So we discuss and then we have identified something like, for example, Code Combat for programming purpose, Wireshark for communication and network. And for chemistry and biology, we use a ChemDraw to ensure that teaching activities to meet the learning outcome. So once we select the module, then we have planned for a workshop to conduct to run through this idea. So basically, we have conduct a 2 hours workshop. So basically, we have identified the topic that we want to run through this particular initiative. Like, for example, we have about 12 weeks. So from the 12 weeks, we are not running the entire, but then since this is a pilot or study or something like that. So what we did is we select the proper topic that we can incorporate this particular initiative, and we conduct 2 hours workshop. We schedule based on the student availability, venue, and other constraints with the ongoing teaching activities. Then we provide them with the consent form, because this is involving the students. So we come up with a consent form, and we collected the consent form. Yeah, the workshop was conducted. So at the end of the workshop, we distribute a survey form, so that we can identify the student feedback, or we can collect the student feedback. Not only on the student, we also collect from the lecturer side to see what they how they feel on the effectiveness of incorporating such initiative in their module, especially to see the student engagement, or whether the objective is met or not. Yeah, so this is on the methodology. So basically what we get, okay, for programming module of for workshop that we arranged, we use Code Combat. This is like game-based coding platform. It's very similar, very simple, but then we use this for one particular topic where we use for control structures, and then for looping and repetitions part. This is one of the topic that we would like to test on. And then slowly we increase the complexity of the activity that we plan during the workshop. And then at the end of the workshop, students need to do or design the role play game scenario, reinforcing programming knowledge that they have learned all that particular durations. I mean, even before the workshop. So the results that we obtain through the survey form, we measure on the 4 area here, 4 metrics here: the engagement, student engagement, interest, the enthusiasm, and then how the focus, I mean the student focus, and the effort. This is mainly on the effort of the student in completing the tasks that given during the workshops. So these are the 4 metrics that we measure through the survey form that we collected. So surprisingly, we can see that the student engagement is 90, and then the interest is 83, focus and effort is above 85. Yeah, so this is for the programming module. And then for communication network, this is more on the networking module. We choose Wireshark to introduce the foundation student to analyze the network traffic. Normally, we won't give this sort of applications for foundation level students. This is more on the undergraduate and above. But for this initiative, for this study purpose, we have selected Wireshark. And then again, the similar method was carried out, whereby we conducted 2 hours workshop by designing a simple task using these Wireshark applications. And the feedback that we collected is, again, the student interest is 61. So each of this workshop is roughly participated by 50 to 60 students. And this particular module, like communication network, is core module in our program structure, whereby students from various progression pathway will participate in this particular module. Like some of them are from the environmental science, some of them are progressing to computer science, some of them are progressing to bioscience, some of them are progressing to pharmacy, and so on. So this module is a core module. So the number of students who participate here is like mixed. It's not only those who are progressing to computer science who have a little bit more knowledge on the networking side. But then, yeah, the results is showing a good side of positive feedback. It's above 50, yeah, average. And then talking about the interest, yeah, we have split for this particular module. We have high interest and moderate interest. Again, it's good number compared to the other modules. And the focus also 46. So this is on the communication network. And moving on with the other two modules, biology and chemistry. So for this particular module, these two modules, we combine the activities whereby the first 1 hour, the chemistry lecturer will introduce the topic and then continue with the biology lecturers. And we use ChemDraw, and this is a powerful tool for visualizing a molecular structure and chemical reactions. So that the workshop purpose is to teach the students how to see the molecular structures and chemical reaction, where normally students finding it very difficult during our lecture classes to understand the topic. So by using this particular tool, we try to do some sort of simulations or visualization to the students by doing certain activities, incorporating certain activities to see whether the student able to solve the problems or not, and observe the complex processes like glucose conversion into cellulose and starch and so on. So the results here, again, with the 4 metrics: engagement above 90, interest is 83, and the focus is 87. The effort in completing the task is 85. So with all this feedback, we found that this approach, whereby the simulation-based kind of approach is really works to help the student to understand the theoretical concept. And it's very easy for them to do or in completing the task. And not only that, but the engagement of the student throughout the 2 hours workshop. I mean, in this case, it's a workshop. And in normal condition, is in our classroom. It can be like 2 hours classroom or 2 hours lecture or 1 hour lecture. The engagement is very high. And the effort, the students are with the lecturers throughout the 2 hours to complete the task. So that shows the positive part of that particular approach, implementing that particular approach. So this is on the student side. So we also conduct a survey on the educator sides, collecting their feedback, what they feel when they run, what sort of benefit that they are getting when they run this sort of simulation-based learning approaches in this sort of technical subjects. They notice that the student engagement is drastically improved. All of them are reported significantly improved student engagement compared to the traditional method. Means that the normal classroom whereby we give the paper-based activities, or even sometimes we use Kahoot or whatever online platform and all that. Compared to those methods, this sort of simulation-based activity that we conduct for this particular study purpose shows a drastic improvement. This is the first comment that they have highlighted through the survey. And then the participations, all of them, all the lecturers who participate, they say that 75% is observed the participation is good. And it was like more dynamic classroom interactions, like the Q&A section is like, is there. That shows that the students really follow the lecture throughout the particular durations. And then the next part is experience of implementing this sort of approaches in their classroom. This part, like we collected 50% of them, they found implementing STEM-based or even like not really like simulation-based or problem-based or inquiry-based learning kind of techniques. 50% of them find it easy, while some of them say that this is okay, and some of them are finding challenges. This is only those who participate in this engagement, I mean this initiative. But throughout our knowledge sharing session among other staff in the faculty, again, we found that some of them, I mean, half of the staff over here, they find it some sort of challenges in implementing this sort of approaches in teaching and in their teaching pedagogy, in teaching methods. And then some of them required that they need to improve the skill development in terms of problem solving. And the best part is they need to they can see that the need for repeated explanation is reduced when the student able to visualize the theory concept in actual simulation based learning environment. So that is the best part that they have highlighted here. And other than that, benefit and challenges that they face, like talking about the benefits, as I mentioned earlier, it's helped the practical application, develop the critical thinking, improve the conceptual understanding, and it's like more structured in interactive teaching. These are some of the prominent key benefits that they have identified. But at the same time, they also mentioned that implementation challenges in terms of times and constraint, like for preparations, like preparing the activities which is following the actual simulation based learning is like one of the big challenge for them, for the module convener or for the lecturers. And then, of course, like in a classroom, we have like different levels of students. So we have to cater, I mean, we have to design a questions which is like meeting everyone. I mean, the questions should be suitable to everyone. The other thing is about the technical issues, because when we run this sort of simulations, like especially the applications or the softwares that we are going to use may consume like high hardware requirement, even like internet and all that. So that is another part of like technical issues that they encountered. And then, of course, to do this, we need our institutional support in terms of budget, like, purchasing the softwares and all that. And beside that, they also required for training, more training on how to design the questions, like simulation-based questions or STEM-based activities for the student, which match the learning outcome of the module. And then, yeah, the assessment, if like they plan to implement this in the assessment, how should we design the assessment? So this sort of guidance, they expect to have some sort of like support. Yeah, so these are the challenges and the benefit which identified by the lecturers. So basically, after we run through this particular study, it shows like a very positive impact in our teaching, not only for the four modules, but even, as I said, that the knowledge sharing session with other staff members, and some of them are start to implement in other modules, shows that it is a good impact of this particular approach. So in future direction, we want to do a CQI, continuous improvement, quality improvement. So at the moment, we implement this in a foundation level for certain modules. Probably in a coming semesters or coming cohort, we plan to implement this with the more modules at different level, like for example, even in undergraduate and postgraduate level, based on the suitability of the modules. So of course, we need to have like a team or committee to decide on which module that we want to implement this sort of approaches, because we believe that not all the modules are suitable to be to have this sort of activities, because the nature of the module and the learning outcome of the module. So this is our future direction for the module, I mean for the study. So in conclusion, simulation-based learning enhance the student engagement and understanding, and improve the active participations. And on the lecturer side, it helped them to do a better lesson delivery and improve problem solving among the students and more dynamic classroom environment. And other than that, other technical issues and constraints need to be identified, and then need to be prepared, so that we really can implement this, and the positive impact on the both teaching and learning. And most of the educators plan to continue using this simulation is a good sign of the study. Yeah, so that is of this the conclusion of this particular study. So I'm done. Any questions? I'm happy to answer.